here we are. So, hello everyone. How are you guys?
Hello.
Good, how about you?
So, this was our first week working in groups. I'd like to know how did you feel about that, to hear some experience or feelings about the group work. Do you want to share something with us? Someone is running. Oh, yeah. Yeah, we.
It was good. I enjoyed working in a group with Will and John.
Mm-hmm.
It was just tricky and difficult trying to make sure we can all meet at the same time, because the 1 week time frames tend to be really short.
Mm-hmm.
But I mean, Cloud9 made it really easy to sit and work. We just hopped in a hangout, and it was not a problem.
Yep.
So.
Yeah, exactly. That's the main idea of a collaborative IDE or text editor. So you can all stay tuned in the same place and see the code that everyone else have written, you know.
Mm-hmm.
And about the timetables, yes, it usually happens that it's difficult for you to find some time to meet all together, but it's really important to make an effort on that, because you know it's completely different work alone and work with someone else. It's just really different, and you have to try to work with your classmates as much as you can, because that's what makes this course different, you know.
Mm-hmm.
So and did you manage to meet during the week, or it was impossible?
No, we figured it out. We had I think a false start one of the days, but we met I think 2, maybe 3 times and finished it up. It was fine.
Okay. What about the other group?
Yeah, we met twice. We met
twice.
Yeah.
Really?
Yeah,
Wow,
Thursday
that's
and
amazing.
Today.
Congratulations. How long? Like half an hour or a full session of 1 hour, 2 hours? I don't know.
No, the
Tell me a
first
little
one
bit
was
more about
like
that.
2 hours. 2 hours we actually sat and did all the architecture of the tic-tac-toe, and then yesterday was a short one. We just went over the other 2.
Okay, great. Perfect. So aside from the group work, what about the individual readings and assignments?
I mean, aside from number 2, I think I got it, but I don't think I got it the way you kind of asked for it.
Mm-hmm.
Wait, which one was number 2?
That was it said to use 2 nested list comprehensions.
Yeah, I did not get that.
That's
at
a
all.
really complicated assignment. I know that. I know that. All the students have issues with the same one.
Yeah, no, the nested list comprehension got to me.
Okay,
we're
going to go through the assignment here in class, and you are going to see that if you split things correctly, it's not that hard. We're going to go step by step there, and believe me, you're going to get it. Well, aside from number 2, I think most of you have done all the assignments. That's amazing, and congratulations for that. It's really important that you attend the class having read all the readings and also resolve all the assignments. Is crucial for the class, because I'm going to suppose that you have the concepts in mind, you know. Okay, so first of all, I'd like to see some of the results of the group assignment. Do you think that you can share something with us, make a quick demonstration or something?
Sure.
It doesn't need to work. Just share with us what you have done, or the code, or if you have any question, comments, something you want to share with us, that would be great. So group 1, I don't remember the members of the group.
Yeah, we are group 1.
So Neil and Sadaship, right?
No.
Yeah, and Abdul.
Okay, great. Yeah, sure. Okay. So, do you want anyone that can share the screen and show us some code execution or just the code? if you want to explain what you have done. Come on, anyone?
Were we group one, or is the other group one?
What?
You guys are group one.
Yeah, you guys are group one.
Yeah.
Yeah, group one is Neil, Sadashib, and Du. So I think you have worked in Cloud9, right? You know, to access Cloud9 class 1, and it's, for example, I'm the most interested in the tic-tac-toe assignment. That was the hardest one. Is it working, actually, or not? If it's not working, it's okay. Just let me know. We can go through it.
Yeah, it is.
Can you guys hear me?
Yes, I can hear it.
Oh, okay, all right. So I won't be able to do a video because I traveled, so I'm not on my computer.
All right, no problem.
Yeah, all right. Okay.
Anyways, you are in the room number 2. So now, Neil or Sashib or Duke, can you share the screen and show us the code or the code execution or something?
Is anyone else getting really bad echo? I'm hearing everything like twice.
No, I'm pretty good.
I'm fine.
I might just sign back in.
All right.
Go ahead. I'll be right back.
Okay. So let's do one thing. Let's just switch to group number 2 until Neil is back. Can you guys share something with us?
Yeah, I think.
Yeah, I can. Oh, okay, you got the screen share?
It doesn't need to work, you know. Just share what you have done with us.
Yeah. Can you guys see the screen share?
Yes, I can.
Yeah, we got you.
All right, I'm back.
You can see this.
Yeah, perfect.
No.
All right. So you're showing it.
Okay, so I guess, all right, so this is tic-tac-toe. When we first started this, we kind of just thought about the structure of the whole program, and we kind of just started defining what we thought as the crucial functions.
Mm-hmm.
So obviously, drawing the board, as you see here, which we would call initially to draw a blank one, and then after every turn.
Mm-hmm.
And then after that, we came up. We thought it would be important to check when the board is completely full. Then you wanted to reset it. So we have a function called isFull.
Mm-hmm.
Obviously, if you detect a winner, you check it with this function. Let's see. Yeah, okay, so isWinner, isFull, and then after every turn you will want to check if that option that the player entered is actually empty, so that's done with isTileEmpty. So if the tile is actually empty, then you could insert the move into it, or else you would have to ask for another option.
Mm-hmm.
Get player input would just ask all the printing and ask what the move the player wants. So then in the main, so when the program executes,
yes,
it creates an empty board, okay, and assigns X and O for the two players.
Okay.
And then you see this while loop right here, which is basically the game loop, and it's running throughout the entire process. So in this while loop, it'll get the player input, and then you can see after every input is taken, we'll check if let's see if the player is the winner, if the board is full. So after every option, you'll draw it, and if the outcomes are reached, then you would print is winner or tie. And then we also made two functions called play again, which would be called after you will win or you would tie, which would then call reinit, and it'll redraw the board and then continue in this loop. So it never gets out of this loop unless you say you don't want to play again.
All right. Okay, looks good. Can you execute the code? Is it right?
Yeah.
It runs.
Would this run on your side or? Hold on, let's see. Workspace.
Class 1, group 1, group 2.
Wait, that's not a directory. Sorry.
You have to enter to class 1 first. Yeah.
Okay.
The main thing differently you guys did was it looked like you put every board position as its own kind of like array, or indexed in an array, and we used a two-dimensional array. So we ran into the issue of kind of like rather than doing like a lookup of each array, we kind of did a we passed in like indexes into the two-dimensional array to get the position.
So we thought about that first. Go ahead. You could explain.
It kind of made it a pain in the ass, honestly. So
yeah, we thought about doing it that way, and then we figured it would be like kind of a pain. And Will's like, "Why don't we use a dictionary?" I said, "Actually, that works really well.
Yeah.
Because we can specify the values as we need." And then yesterday.
It's really important because you have taken a decision. That's when you are planning your software, not only in this kind of games or this kind of toy project. In your whole life as professional, you're going to take decisions all the time. There are good decisions and bad decisions, but the important thing is to think about the problem and just consider all the alternatives you have and take a decision. And if you did that, it's perfect.
Yeah.
I don't know if you guys just saw that. I just executed it, so it runs pretty well. It runs.
Perfect.
Yeah, we did our testing yesterday too.
Okay, so the code looks great. I will say something about let me open in Cloud9. This is tic-tac-toe, okay. I like the way you split all the code into different and isolated functions or blocks. That's really cool because you have split the responsibility into different functions. For example, here the first draw function. This function is particularly responsible for drawing the board, and nothing more than that. And maybe it's not really important now that we are working with this is called like imperative programming or procedural programming, but when we move forward to object-oriented programming, this is crucial. We need to identify the responsibility, and we need to know how to split the responsibility into objects. We're going to see that in the next class, but I'm really happy that you have done this from this moment on. The only thing I would add here, this is a tiny comment, it's not important maybe, but I would add a comment here in every function saying a doctrine, exactly, explaining in a few words what this function is responsible for.
Right.
Okay. Yeah.
So when an external developer is reading your code, it finds this draw function and saying, okay, what is this function doing? And it's going to read the docstring at first. Saying, okay, this function is responsible for printing the board in the standard output or something like that. Just a few words. Because in this case, they are pretty simple functions, but in a future when you are working in a more complex project that you have tons of functional objects or whatever, you don't want to spend time reading the code trying to understand what the function does, So it's very important to read here the docstring and makes your life much easier. Aside from that, looks pretty good actually.
Okay.
Of course, there are a lot of possible solutions. Some are better than other ones, but if it works, it's okay. Do you have any extra conclusions on this? How did the group work, or I don't know, anything else you want to share?
I was thinking actually. For me, it felt interesting because we always had to be conscious of returning values and passing values in. And I mean, I don't have experience with this, but I thought like a lot of the code that I read on GitHub, what they do is they have different classes so that variables can be shared among functions better. So I thought if we had gone over classes.
So instead of passing variables as arguments, you are storing. I didn't get that part. Can you repeat that?
Oh, I'm sorry. So instead of calling functions and passing like the board back and forth, we could.
You have like global variables
in a class. Yeah.
You have global variables. Yeah, okay. Sure. Oh, because you are defining the board here.
Right.
Let me see. Okay, in the main. In the main, you are
Yeah.
defining the board, and you are passing the board to every function that needs the board. Yes,
Yeah,
of
we
course. You can. In this case, you can define a global variable called board, and every function is going to be in the scope of every function. You know.
right.
Do you understand me when I'm talking about not only you, Yatri, but everyone? Do you know what is the scope of a function? Or you're not familiar with the concept?
Right, it's just
Really
variables
important
that are
concept.
within the function are local to that function and are not accessible outside of that function, basically.
Exactly. So the scope for a function is what that function is able to access. Which variables, which functions, or wherever the function or the block is able to access and what no. And if we define a global variable on, for example, on top of the file out of any block code, that variable is going to be global, so it's going to be accessible by any other function in the code. There is a problem with that. Well, if it is only a variable, there's no problem, but suppose that instead of defining just a board variable that is a dictionary in this case, suppose that you have a variable globally defined that is the result of the execution of certain method, you know? In that case, you have to take care on that kind of cases, because every time you import the module from anywhere else, that code is going to be executed, and that can be really dangerous. For example, I know it's common to see some code when you use connections to databases, for example, and you want to define a global connection object for MySQL database or something like that. And I used to see, for example, for some developers in the company, that they create a global variable called connection that is actually connecting to the database, you know. And you know how the connection is going to work. Maybe you have a timeout, or it takes 10 minutes to connect, or wherever, and every time you are importing the module from somewhere else, that variable is going to be assigned, the code is going to be executed, and it's probably going to be hanged in that line for a few seconds. Do you see the problem?
Right.
So take care with global variables. If you're really confident about how long it's going to take the execution of the global code, and that it's not going to be dangerous if you are importing the module from somewhere else, it's okay, no problem. If not, you have to make some tweaks to solve that. Okay. Anything else you want to share? Group number 2. Which was the most challenging part you found?
I think we hit a wall yesterday with the isWinner function.
Mm-hmm.
We kept thinking about how to do it in a way where we didn't have to kind of do every permutation of the row.
Yeah.
I sat and I looked up, the collections module and like how to use permutations and making a generator and all of that, but I couldn't figure out a good or simple, easy way to do it, so we just kind of gave up.
It's okay. Actually, in the solution I made when we were writing this assignment, I used something similar to this. I mean, at some point you have to specify which are the valid solutions.
Right.
If you're not, if you don't do it with an if statement, probably you are going to use, I don't know, a dictionary or a list or something to store the valid solutions, and somehow you have to compare what you have in the board with the possible solutions. You have to do that. You don't have any other chance. Okay.
Yeah, our tic-tac solution is basically the same as theirs. I think the main difference was we used the 2D array, which led to some headaches in kind of converting the A1, B1 strings into numbers, and then plugging those back into the board array. And then we also
Neil, can you share the screen and show us the code and
yeah,
give
sure.
a quick explanation of the architecture you have chosen?
Sure. Let's see. Screen share. All right. let's see. So this is our code. You guys can see my screen now.
Yes. Mm-hmm.
Yeah, we can. Yeah.
So we set up the board with this 2D array. This is just a list comprehension that spits out blank in the array.
Mm-hmm.
And we did things a little bit differently. So checking if things were blank, we would just say, if not equal to this. We originally tried it with none, but it was a little bit different. We've got the same game loop, and we put in a global counter. So instead of checking if the board is full by checking to make sure that there were no empty positions, we checked to see if the count was at 9. And that's why we had to move the global counter so that it could be checked inside the other functions. And I'll show you the main thing that's different for us here than was, so here is the inputs, and we had the whitelist, and you could do this with the regex, or you could lower these to make this simpler. It's just explicit here. But the main function that's more complicated for us was this insert mark where you actually place the X or the O. So if you look down here, the main problem is if you've got A1, B1, and you're not using a hash or a dictionary like Group 2 did, which I think is better for a small board like this. I had to convert that A1 and B2 into the array equivalent of 0, 1, or 2. So for here, I looked and I said, the first part of that string, if lowercase is A, then that equates to 0 in the 2-dimensional array. If it's B, it equates to 1 or whatever. And then it was kind of a headache that I had when I returned this. It came as a tuple, which wasn't an int, and I had to realize I had to change that to an int so it would work, because I was ultimately passing it in here, which basically was inserting, so board, position, row, but they had to come as ints and not as strings. We kind of had this helper function to convert the string into 2 ints, and then ultimately be inserted. So that was just kind of the runaround we did by not using a hash.
All right, great. Yeah, it looks amazing too. It's working, right?
Yeah, I ended up duplicating some code. I wasn't sure if there were better ways to do it. I pulled out the position to tuple or tuple or however you say it here, but then I found that each time when I was returning that, I needed the 1 and 2 each time, so I had to separate the tuple here and here, which I didn't really like doing. It seemed like a kind of bad way to approach that.
Mm-hmm. Okay. I would like to make you a question, not only to you, Neil, but all of you. How difficult do you think that it would be to extend this tic-tac-toe exercise to be generic, to be configurable to more than 3 per 3 positions in the board? Now suppose that you can start the game and say, okay, how many rows or how many columns do you want to have in the board? I don't know, 10. And you have to extend the tic-tac-toe game to support bigger dimensions. Do you think that it would be really difficult to extend your code or update your code to support that?
I think it would come down to the arrays, the way we created the arrays, and also how to check what is a winning combination or what is not.
Exactly. The problem always with everything is hard coding, and if you have hard coding there, you don't have a generic code, and of course it's not going to be possible to extend that. Or yeah, it's going to be possible, but you're going to need to do it single line
manually. Yeah.
So we are not going to do that, but if you have some time and want to have some fun, you can extend the code to be generic and to support configurable dimensions for the board. It can be challenging.
All right.
Yeah.
All right. So, guys, you did a great job. I would like to congratulate you because of 2 things. First of all, because the group assignments were amazing. The solutions you did, all the group work you were supposed to do, and also because you have done all the individual assignments. That's really important because based in previous experiences, we have seen that it was not easy for our students to split their time correctly between the individual readings and assignments and the group work. They were just like really having fun resolving the group assignments and meeting all together to work on that, and they completely forgot about the new concepts for the next class and the assignments. And that's not what we want. You did a great job. You managed to divide your time perfectly, and I'm really happy with that. So I want to point this because I want you to keep doing this. Split your time and take your time to do the individual stuff and also the group work. They are both important, and you don't have to forget any of those. Okay?
I have a question. Are you going to go over the second question in the assignment? Because I just couldn't do it, and I heard other people.
The second, the second exercise, the second individual assignment. Yeah, we're going to solve that here in class. It was a really tough assignment, so we're going to take some time to go through it. But before that, I'm going to make a quick review of the concepts we're going to see today. I will share some slides. Give me 1 second. Collections. Okay. Let me share my screen. Here we are. Okay. Do you see my screen there?
Yep.
Yeah.
So you were supposed to read for today everything about collections, right? I'm not going to spend much time on this because this is pretty basic. I'm sure you have already read about this and you know most of the parts. But this is nothing new. We have in Python, we have 3 main types of collection: lists, tuples, and dictionaries. As you may know, a list is able to contain different types of data. I mean, in other languages, it's used to have a list or this kind of collections that can only store data of the same type. So, for example, only integers, only strings, or whatever kind you can configure. Python is not that way. You have homogeneous lists or collections that you can store anything you want inside. In this example, we have integers, strings, Boolean values, and also another list containing the same collection. So related to or regarding lists, do you have any questions about the readings? Is there anything that you couldn't understand about the readings and regarding lists? It's pretty clear. Okay. So, oh wait, I was supposed to move here. Okay, do you see? I was moving the incorrect slides. That was the example I was pointing. And similar to the list, we also have the tuples. Can anyone tell me the main difference between a tuple and a list? You have there the text, but they are pretty similar, but they have one main difference.
So tuples cannot be changed, so you can't add values, remove values, or do anything to change a tuple.
Exactly. So the conceptual word for that characteristic is immutable. You know, once the tuple is created, you cannot change the content. That is really important, and sometimes you really need that. You don't want some things to be modified, and that's the correct moment for use a tuple. Something important too is that it is ordered, so they are respecting one particular order, same as lists. Okay, so if this element is in position number 0, it's going to be there, and the position is important because when you are iterating through the list, the positions are going to be respected. Okay, same for tuples. And then we have sets. What can you say about sets? You were supposed to read this in the mandatory readings.
Well, they're supposed to have unique values, so I don't think this would be an allowed set, so that second one shouldn't be allowed there.
Exactly. So the main difference between tuples, lists, and sets is that sets cannot contain duplicated values. You know, here I'm highlighting the number 1 because if you check this, this is a list inside that you are converting into a set. The way to convert a list into a set is just wrapping the list with this set built-in function. And as you can say here, the set is mutable, so you can edit the content. It contains only unique values, and look at this, it is unordered. So the order doesn't care for sets. You're not going to have a particular order for elements. Check this, if we are converting a list into a set, automatically all repeated values are removed. So this is a fancy way to remove all the duplicated values from a list, for example. You can convert the list into a set and then convert the set into a list again, and you have the original list but without any repeated values. It's really fancy, and we used to do that a lot. So whereas dictionaries is pretty basic. I'm sure you already know this, but it's a key value collection or data structure, pretty easy. And then we can start with the list comprehension. So before moving forward, do you have any particular questions on how to operate with dictionary sets or lists or tuples? I mean, how to add an element, how to remove, how to get the index of one element, anything you can do with this kind of collections?
No,
Nothing.
no
Okay.
problem.
It's really basic stuff, but I just want to be sure that you don't have any questions on that. So list comprehensions. This starts to get a little more complicated, but I'm pretty sure you already understand it. I'm going to show a quick sample here. Suppose that we want to square all the elements, all the integers numbers in this list. We can do this for loop, pretty basic. We create a new empty list, and for every element in the list, in the original list, we are appending the square of the element. It's pretty basic, okay? Well, in Python, we can do that. We can do this exactly the same in one line with a list comprehension. Do you guys understand conceptually what a list comprehension is?
Yeah.
It used to be a really complex topic in Python, and a lot of people have a really hard time while understanding this. How did you find that?
I've seen them before.
Are they used in other languages, or is this the equivalent of like a block in Ruby?
Oh yeah, sure. Okay. So for all the people that knows the concept from other language, maybe it was easy. But if you don't have the concept, maybe sometimes it's hard to understand what is happening behind the scenes. You know, there in the list comprehension. So all of you have the concept of the list comprehension. Not necessary for me to go through the concept and explain exactly what it's doing, right? Please stop me because it is a really important topic. Okay. In the line in the middle, we are doing exactly the same that before. We are going through all the elements in L, and for each element, we are returning the square of the element. The result is exactly the same, but we are saving a couple of lines. This is the syntax for the list comprehension. We're going to go into details now. Another example. Okay, nothing important here. What I want to say now is that list comprehensions, not only list comprehension, you know that we also have dictionary comprehensions. I mean, comprehensions in general are topics that are some kind of related with functional programming. We have in the background some built-in functions related with functional programming that are supporting list and dict comprehension, and that is what we are covering now. Let me share the screen again, but now with other slides. So I'm not sure if you are familiar with map, reduce, and filter functions, not only in Python, but in general. Have you ever heard about that?
Yeah.
All of you?
What was that?
You know, in functional programming, there are some well-known functions called map, reduce, and filter. Anyway, we're going to cover them now.
Okay, all right.
Yeah, I only learned about them now, but it sounds like, from what I read, that they were originally from Lisp. They pulled them in, and
yeah, exactly.
It sounded like he was actually talking about getting rid of some of them, especially reduce at some point.
In Python 3, some of them they were moved into an external package. I want to show you. Okay. So let me go back a little bit. Let's start. Do you remember this that we have seen in the previous class? High order functions or functions as first class objects. Do you remember that?
Mm-hmm. Right.
When we were describing the language, and particularly when we were talking about functions. Can anyone repeat me or explain me what this means?
So functions are... go ahead, I'm sorry.
Okay, well, essentially functions are first-class objects, meaning they can be passed in as parameters. They could be used to perform regular operations. For instance, my sum equal add. Add is actually a function, but you could actually say add plus add, kind of, because it is a first-class object. You could pass it as parameters, right?
That's correct, but in general, what it means is that functions can be used as any other object in Python. I mean, it's an object. A function is an object. That's why we say that they are first-class objects. They can be used exactly as any other object in the language. So once we know this, I'd like to introduce the concept of immutability. Have you ever heard about this? It's a really important thing. Maybe it's not important the first time you see it, but after some experience working in big projects, you can really understand why it's really important. Is there anyone that can explain this very quickly? Immutability, the concept.
I would say basically it's a way of manipulating lists, maybe dictionaries as well. Basically, you can add stuff, you can remove stuff from a list and dictionaries as well.
Okay, yeah, that's correct from the point of view of the data structures, but this is like a more general concept. I'm going to make a quick introduction. So, take a look at the example we have here. We have a list, and we perform a sum operation between this list and a new list containing just one element. Okay, this is going to return a new list because we're adding two different lists. You see here on the bottom part, you can see that new list and a list contain different things. Okay, but on the other hand, in the right part of the screen, we have an operation that acts on the same variable. So the result of this is going to modify the content of the same variable. Take a look at the next example. In the left side of the screen, we have an example of an immutable function, and in the right part, the mutable one. Do you see that the add element function is adding this element that we have as parameter into a list, but this is returning. I'm going to make a question here. This is the same list, or it's a new list containing one more element?
It's a new list.
It's a new list.
It's a new list. So if you see here, on the execution of the code, we see that a list contains 1 and 2, and when we add the number 3, we get a new list. But when we compare, do you know the ID built-in function in Python? Have you ever used that?
I use type though.
Yeah, type is another one, but ID, what we get there is like an ID of the memory address where the variable is stored. You know, that's really handy to check if the variable is actually exactly the same or not. So for that, if you check this, the variables has, of course, different content. The original a list variable contains 1 or 2, and the new one contains not only those elements, but also the one we have added. On the other hand, we have the mutable example on the right. You can see that the parameters are exactly the same. Actually, the function is called exactly the same. But this in this time, we're returning the same list with one element. So the element is appended to the same variable, not to a new one. The function is returning the same variable and not a new one. That's really important. And if you check this, we are assigning the result of the function to this new list variable, but also a list is being modified. Do you see the difference?
Yeah.
Or it's kind of confusing. Please let me know, because I'm going to go through this and really want you to understand these topics. It's kind of confusing. Do you see the difference?
Yeah, I understand.
Seems to be pretty similar, but conceptually it's completely different. On one hand, hey Sean, I didn't see you. How are you? On one hand, we we are sending one variable and we are getting back a completely new variable with the new element. And on the other hand, we are sending one variable and we are getting the same exactly variable, but with one element. And which is the difference? Picture that you are working in a very big project that you didn't write. Someone else wrote the code, and you have a function that makes some modifications on a collection, and you are not sure actually what the function is doing. You don't want your data structure to be modified if you are not sure what is going to be happening there. So what we try to do always is to create immutable code. I mean, if you are creating a function that is going to modify somehow a list, don't modify the original list. Create a new list, return the new list, and the person or the user of your code is going to know exactly which is the difference between the original and the second one. It's not going to make some unexpected applications on the data of the user. Make sense what I say? This is like a good practice. I mean, this is something that you're not going to be able to read in books generally, but I can say you from my experience that working with mutable code is sometimes a pain in the back. You're sending some data to some function and you have no idea what's happening there. You're not really sure how the data is coming back, and the original data was modified. That's a problem.
Right, and with list by default, if you set a list, like a new variable, equal to an old list, that will actually be mutable, right? It'll just reference it and have the same ID. It doesn't create a new list.
I didn't get that. Can you repeat it?
So say I have you've got a list equals 1, 2, right? And now I say just b list equals a list. Those both have the same ID, right?
Yeah, exactly. Actually, b list is just a pointer to the same variable.
Right.
So if you are modifying b list, you are also modifying a list. That's really important.
Right. And if you want to copy it, then
yeah, you have many alternatives to copy it. For example, you can use list comprehensions to copy the list. You can do just element for element in a list.
Right.
And as the list comprehension is always returning a new list,
right,
you're actually creating a copy of the list. So, immutability. Did you get the concept? Conceptually what it means? Okay, great. So, moving forward. Do you have any questions so far? Before we keep moving? Nothing? Okay. We didn't cover really complicated stuff. So, let's go ahead. Lambdas. Have you ever read about this? I'm pretty sure it was included in the mandatory readings. I'd like to hear some explanation. Anyone that can explain me what a lambda is?
A lambda is essentially like a throwaway function. You instead of defining a function and then referencing it, you could just define it in line.
Exactly. We used to call them anonymous functions because just because they don't have an actual name, you know.
Yeah.
It's actually pretty basic. We can define the same functionality like we do in a function, but just in one line. Actually, we cannot perform many sentences or statements in the lambda, but for pretty basic functions, sometimes it's really handy to create a lambda instead of writing the whole code for a new function. Okay. Now that we have the concept of a lambda, we're going to move to some concepts of functional programming. And this is the map function I've mentioned before. Have you ever heard about this, what a map function is? Okay. Anyone, not Yatri, that can explain me what a map function is? Come on, guys, don't be shy.
I think it just applies the first function to every part of the iterable.
Exactly. It's pretty simple. So you're sending two parameters to the map function. A function and an iterable object. That this could be a list, a tuple, or wherever that can be iterable. Okay? And what this map function is doing is just applying this function for each of the elements in this iterable. Look at this example here. I'm sending a lambda function, and I have the iterable list with four elements, 4 numbers. What is this lambda doing?
Finding the square of each of the elements within the list.
Exactly, getting the square of each element. So the syntax of the lambda is the lambda keyword. This x, it's like a parameter. You can put here whatever name you want. X is the value. Each of the values in this list is going to be x for each of the iterations. And after these semicolons, you are specifying what this lambda is going to return. In this case, you want to return the value of x multiplied by the same value, so the square of the value. And this is what we get when we execute this. We're just getting exactly the same amount of elements. That is important. We're going to see that later. The map returns exactly the same amount of elements, but optionally modified somehow. In this case, we're getting not the original elements, but the square of the elements. Make sense?
Yeah, and what is the difference? So, compared to a list comprehension,
exactly. Yeah. Look at my next slide.
Okay.
Sound familiar? Yeah, of course. It's pretty similar to a list comprehension. Actually, they are the same. List comprehension is, we're going to see that, but it's like somehow on top of all these map, reduce, and filter functions, and it's just more prettier way of doing the same. So these two lines are exactly the same. X multiplies by x for x in the list. This list comprehension is exactly the same that applying the map function with this lambda to the iterable. Make sense?
Yeah.
Is either one faster in Python, or are they basically the same?
They are basically the same.
Okay.
Actually, I'm pretty sure that the code, the really low-level code that is going to be executed, it's the same. So, what else? this was the map function. We're going to move to the filter function. It works in a pretty similar way. We have a function and we have an iterable, exactly the same as the map function. But do you know what this is doing compared with the map?
No.
Anyone?
It's reducing the even numbers.
Oh yeah.
What?
It's printing out the even numbers.
Yeah, exactly. So what the filter function is doing is getting the iterable offset and filtering out all the elements that are not matching with the condition that we have inside the function. This function is just a function that returns true or false. So we have some conditions, that whatever condition we want, and based on that condition, we return true or false. If the function returns true, the element is going to be included in the result. If the function returns false, it's not going to be included. In this case, the condition we are setting is x is divisible by 2. This is the way we do that. And this, of course, can return true or false. And based on that, the element is going to be included or not. So, for example, for the number 1, x is going to be 1. X is divisible by 2. No, then the number 1 is not included in the result. Make sense?
Yeah.
Okay. Something important to notice here is that the elements in the result are the same elements that we have in the original list, but optionally, some of them are not there. I mean, the elements are not modified, but some of them can be filtered out. Okay, that is different compared with the map. Remember that the map only returns the same amounts of elements, but modified. And in this case, we don't modify elements, but we have different amounts optionally.
Wait, can you elaborate on exactly like the significance of like what you just said?
What?
I'm not sure that like I totally understood the implication.
Okay. Yeah, I think we can move to Cloud9. I'm going to show you a more detailed example to show this. Can you follow me to Cloud9? I'm going to wait a second, where I have the Cloud9 here. Let me change my screen sharing. Here we have. All right, I'm going to create a new folder here. New file. There we have. I'm just going to copy this example in the slide. This here. Here. Do you see my code there?
Yeah.
Okay. So, on one hand, we have the map, and I'm also going to copy the reduce. No, the filter function. I will just comment this for now. Map, okay. I want to show you exactly what this map function is returning. First of all, I want you guys to be sure. Want to be sure that you understand this. The map function as first argument is getting a function. I mean, in this case, we were using a lambda, but here we can set whatever function we want. For example, to define this quickly, function. Of course, the function has to receive each of the elements as parameter. So element, and this is going to return something. to implement this later. So let's return the square of the element. Okay, I'm going to print this out, see what we have there. Do you see the code here? The execution? Okay. So I just want to be sure that you get this. Not only you, Sean, but all of you. Do you understand how this is working? Yes or not?
Yes.
This function is applied to every single element in this iteration. In the first iteration, the number 1 is being sent to a function. The lm parameter is going to be 1, and it's returning the square of 1, that of course is 1. And the same is going to be applied for all the elements in the list. This is the map function. What I wanted to say before is that the amount of elements that are returned in the map function are exactly the same that the original list. You see that we have 4 elements here, and we also have 4 elements in the result. But the elements inside may be different. In this case, they are different. These were the original values, and the result are the square of the original values. Do you see that?
Yeah.
Okay. And what I wanted to say about the filter function and the difference between these two functional programming functions is that, let me execute this code. This filter is going to filter out all the elements that are not divisible by 2. I'm going to execute this. So let me print here map and print here. So what I wanted to say is that the map function is always returning the same amount of elements, and the filter function optionally returns the same amount or less elements. Do you get that difference? But the elements in the filter functions are always the same elements as in the original list, and in the map function they usually are different, they are modified. Did you get that, Sean?
Yeah.
Do you see the difference? Okay, great. Should we move forward?
Can you have more complicated functions in map or
sure.
in filter?
Like
if I want to do like an if else ladder, can I do that?
Sure, you can get as complex as you want, but if you are using a Lambda, you don't have much options. But you can use a really function that, like in the same way I did with this f function here, and you can put here wherever you want. You can put a whole algorithm here if you want, and this huge function that you're going to have here is going to be applied for each of the elements in the list. You don't have any limit there. You just have to return the element after all the modifications you want to do. Great. So we have filter, we have map, and the last one that we are going to cover is reduce. Reduce. I'm going to copy this example from here and go into Cloud9. There we have. Does anybody know what the reduce function does? Nope. It was not included in the readings.
It returns a single value.
Returns a single value. That's a really important comment. Thank you.
It iterates down the list from first to last element, and it applies the function from like 0 to 1, 1 to 2, 2 to 3. It's I guess it's kind of like recursion in a way, but
exactly. Internally, for sure, it's using recursion. So basically, what it's doing is taking pair of elements and applying this function to them. I'm going to remove this third parameter because I don't want to make it complex now, but I'm going to explain you later. So we have a function. Again, this is a lambda function, and we have an iterable list here. What the reduce function is going to do is first take the two first elements in the first iteration. No, wait. First is going to take the first element and is going to send this element as, in this case, x. And this is going to be like an accumulator, you know, that's going to start by default in 0. And in the first case, based on this function, it's going to sum number 1 to the accumulator that is 0. So for the first element, we have just added 1. It's doing the same for the second one, but keeping the accumulator from the previous iteration. That is, at the moment, it's 1. So it's adding 1 plus 2. That's 3. And it's doing the same for every element, containing here the accumulator and adding to each of the elements in the list. So what you get finally with this execution is for 7, 10. You see, it's like a way of aggregating all the elements in a list, somehow, based on this function. Make sense? Or not? Please tell me if it's complex or you're not getting it.
Yeah, it makes sense.
All of you?
Yep.
What I would want to understand is what is the use of the comma 0 that you had initially? I don't know if you can talk about it right now. Yeah.
So, exactly. This third value here is the initial value of the counter of the accumulator. Let me print here use, and I will show you how this works. I'm going to remove this and print here. So we said that the expected value for this is number 10. Here we have.
All right.
Okay, we reduced the whole list into the sum of all the elements in the list. And we're not specifying any initial value for the accumulator, but we can say, for example, okay, start counting from number 5. What should this return now?
I think 15, right?
15, exactly. It's doing exactly the same, but in the first iteration, accumulator is not going to be 0, but it's going to be 5. This third optional parameter. Make sense?
Yeah.
Really? Okay, great.
Yep, it does.
So these three are the main. Oh, okay, one more thing. An important thing of reduce is that always returns one single element. That is the reduction of all the elements in the list. In the same way that the map returns another iterable with the same amount of elements, and filter is filtering out the original list into some smaller amount of elements. Reduce is always returning just one element. That's something really important. Okay, now that we are in Cloud9, I'm going to show you the equivalent code between map reduce and filter compared with list comprehension. Let me show you something. That I have here. I'm pretty sure. Yeah. Okay. So I need one volunteer that wants to help me in Cloud9. Let me here. I'm going to comment out all this code. I have here a list comprehension. Very simple one that is squaring all the elements in a list. A list is a variable that I'm going to create here on top. This is a list. And this list comprehension is just looping through all the elements, squaring the elements, but only the elements that are lower than 5. And after that is applying the sum function to the resulting list. Okay? So I need one person that is able to translate this list comprehension using filter, map, and reduce function. Do you see the problem? Do you understand the problem?
Mm-hmm.
I want to write exactly the same behavior, but instead of using list comprehension, I want to use map, filter, and reduce. Who is offering to resolve this?
I'll try, I guess.
Okay, Sean, thank you. Thank you very much.
Okay, so first you want to filter everything out, and then you want to reduce it because you're taking out the so reduce something and then filter something.
Mm-hmm.
And filter lambda x is squared. That was the okay. This is the function, and then the other one is.
You know that nesting things gets really complex quickly.
It's complicated, so it's not supposed to be nested.
Yeah, they are. Yeah, of course, they are supposed to be nested. But sometimes it's better to start by splitting things into different variables or something, and then you can start nesting things slowly.
Gotcha. Okay. So it filters out. So that lambda is correct, right?
Yeah, it's correct. Mm-hmm.
And then the iterable is a list.
Mm-hmm, exactly. So what are you doing there? You're filtering. Is filter what you want to apply?
Oh well, no. First it has to. This has to divide it. If it's less than 5. Hold on. Less than 5 is equal to.
Okay.
Okay, so it gets all the values from the list that are less than 5. And map the x equal to x squared. Oops. Is this not made correctly?
I think instead of a list there, you want what's above.
Yeah, what's in filter?
Yeah, you should like store the result of the filtering into a variable and use that variable in the map.
Okay.
Right.
So second.
Exactly.
Oh, again, then this has to again be something else.
Exactly.
And print. So, okay, so first it gets a list that's all the values less than 5, and then it.
Okay, can you comment out the list comprehension? And I'm going to do that. I'm going to comment this out, and you're already printing the result of this. So let's see if we get the expected results. So we have an invalid syntax. Do you see my screen? Am I showing the screen? Yeah.
Oh.
You have an invalid syntax in here. You have one extra. Yeah, there. Great. So I'm running the code again. Okay, and do you see the error in the screen?
Empty sequence. No,
empty sequence in the reduce function. So the third variable is being an empty list or an empty sequence somehow. Let's do one thing. Let's print here, print second. Let's print here filtering. Let's print here mapping and print. It's kind of debugging, you know. Let's save this and execute the code again. So we have filtering and we get an empty list. Why? Because here you don't need to specify this. That equals true. You can just put x is lower than 5 as lambda. This should work. Let me check that. Yeah, there you have. Now it's working perfectly. All the code.
Oh, okay.
So we have all the separated things here, but do you know how? I mean, can you please nest of all of these functions into just one line?
Should be able to, yeah. Reduce. Go. That's how you do it. So like you copy that.
It's getting complicated. Okay, let's see if we didn't miss any brackets.
I think it's an extra one.
I think it's one extra.
There we have. Okay. So I'm going to comment out this third and this second variables, and also removing this. Hey, I'm back. Sorry, I got disconnected. I don't know how. Do you hear me?
Yep.
Okay. I was trying to say. Okay. Do you see how we're writing exactly the same code but using different functions? In one hand we have list comprehension, and in the other hand we have all these fancy map, filter, and reduce functions that we have just seen.
Mm-hmm.
So basically, you can do exactly the same with these two things, but to be honest, in the industry and in your life as Python programmers, you're going to use a lot this comprehension, and you are almost not using all these map, filter, reduce functions. To be honest, I use at least one list comprehension per day, so just to show you how important they are. Okay, do you have any questions on this? We have covered list, dictionary, comprehensions. We have done a quick review through all the collections, and we have also seen the functional programming stuff in Python. So now, if it is okay to you, we can take 5 minutes off just to grab some drinks or something, and we're going to go through the assignment number 2, that was the complex one. Okay?
Okay.
All right. So I'm going to grab some water, and I'll be back in a few minutes.
Okay, great.